Good day, everyone. Name is David Failing. I'm with Lucas Diesel Systems. And if you just bear with us for about a minute or so, we just want to allow all the people that are logging on just a few seconds or a few seconds here, just so that everybody gets to hear the entire webinar today. So please bear with us, and we will get started in just 1 minute. Erica, is there a reason why maybe we don't see ourselves or Tony? Maybe you could just
I
look.
see I see you and I see myself.
Oh, I see. Okay, now I
Uh,
see. Yep,
yeah,
that's good.
I just see both of you.
Okay, very good.
Should be good.
Thank you. All right, I think we will get started. Again, the name is David Failing with Lucas Diesel Systems. I'd like to welcome everyone to I believe this is the fifth webinar for 2024. And as always, this is a monthly series of webinars sponsored by Lucas Diesel Systems. And if you have any feedback with regards to our webinars, we would certainly appreciate hearing from you. In just a few, towards the end of the presentation, we will have contact information up there. A few housekeeping items. First of all, for those of you who are on the webinar live, not recorded, but live today, then you will be receiving a certificate of participation. So keep that in mind. But if you drop off halfway through and so forth, then you will not receive the certificate. So you've got to be with us for the entire presentation. We're also recording the presentation, so the presentation will be available on the Lucas Diesel Systems website in about a day or so. And Tony also places the webinar on his website. So look out for that if you need to have a refresh or you want to share that with your fellow co-workers. In addition to that, we have muted you so we don't have any distractions. However, if you have any questions, please place them in the Q&A section, which is if you move your mouse either at the top or the bottom of your screen. And in that way, we will have the questions and try and answer all of them at the end of the presentation. Let me see. I'd like to just give you a little bit of information with regards to Tony Salas, if you're not a regular here and haven't been with us. Tony is a veteran technician as well as an instructor on light-duty diesel systems. He runs his own shop in Las Vegas, and he has his own training company. Today, the presentation will be on voltage drop testing. So I think another very good, interesting subject. And without further ado, I'll hand that over to Tony. Tony, it's all yours. Thank you.
Once again, thank you, David, for your help and your introductions. And thank you, Lucas, for sponsoring this webinar. And we'd like to thank all of you for attending as well. I'm just in a thank you mood today. There you go. Thank you all. Welcome over to the Lucas Diesel. Yes, light duty diesel voltage drop testing. Voltage drop testing is a pretty touchy subject. You know, as a training provider, I guess I can tell you that one of the hardest selling subjects in training world is electrical, and one of the most needed is electrical. It's a never-ending line, and in this case, yeah, it is a problem. And in this case, I thought we'd do a webinar on light-duty voltage drop testing. So, if you're, I guess the first thing I'm going to plead with you, if you're not very good with electrical and you have never been good electrical, there's a lot of programs out there that teach electrical, and I teach also too as well electrical. But again, with the evolving changes in our transportation industry, whether being automotive, light duty, or heavy duty diesel repair, electrical is a big deal. So therefore, got to get up to speed with that. So, but let's get into this, on what is electricity. And don't worry, it's not a basic electrical course, but we're gonna hit on some terms that lead us to voltage drop testing. And in this case, nobody wants to learn this in the trade. Nobody wants to, I guess I shouldn't say no one, but quite a lot of us tend not to want to learn electricity, and we turn the light off when it comes to electricity. Very important to understand what's going on, but for now, we'll focus on voltage drop testing. So obviously the meter, I would love to have had, multiple stage and cameras to show this, but obviously nothing beats the live thing. But we're just trying to teach a concept here of what you should be doing and a procedure you also should be doing. So in this case, when we look at our meter, we actually are going to be what? We're going to be using it to actually measure voltage, amperage, and resistance. That's the common one. The one thing that some meters do offer is something called min-max mode. And min-max mode actually allows you to go ahead and take a recording and record what the highest, the average, and the minimum voltage was taken from a certain circuit. And what I mean by that is that you can see if a circuit actually goes open or goes grounded, depending on how you actually set it up. So next time you look at your meter, I would like you to set it on volts DC as the one shown on the monitor. And what you can do is just hit the min-max and keep hitting the min-max slowly if it's a fluke type of meter. And what you want to do is you want to see the minimum recording, the average, and the highest. Now, a Blue Point does also offer min-max, and I hear some other ones. Obviously, I can't play with every meter, but you can actually observe what's going on with a min-max mode. But I'll touch on min-max when I continue with diagnostic concepts using voltage drop testing. But let's get hold of some of this stuff. First of all, there's voltage, right? And voltage, let's get it clear. Yes, I have to talk about this because it's voltage drop testing. That is pressure. There is nothing but pressure that's pushing, again, the current. Then we got amperage, which is the flow. And in this case, that's what's flowing into a wire. That is the amperage, okay? Then we got resistance. The name says it all. And in this case, it can be either wanted or unwanted in a circuit. So very important to understand that. Again, resistance, it can be wanted or unwanted. So when we're doing voltage drop testing, like when I'll talk about starter voltage drop testing, you're going to find out that resistance is going to be our number one enemy. Can we have too much resistance? Now, you're probably going to ask me right off the bat, what is resistance when you're saying it's unwanted? That's a popular question I get. And in this case, unwanted resistance means that you got corrosion, right? For the longest time, you have seen the battery cables, for example, at the battery, and you have seen that growth, that's sulfur little mountains that form on the battery terminals, and some of us don't take care of it. We have to clean. That would be referred to as unwanted resistance. Or maybe when a customer changes their batteries and leaves those plastic caps on them on top of the terminals, that could be definitely the unwanted resistance there. In other words, something that doesn't condone to the flow of electricity, which means we need a good conductor. So as we talk about voltage drop testing, you have to have a reference. In other words, where am I going to start off on? And like we said before in other electrical presentations, is that it starts off with the battery. And in this case, that battery must have those 12.6 volts, which is standard battery voltage, but that voltage can actually vary. What do I mean by that? Well, there's what we call B plus. So why do service information or diagrams or service procedures talk about this B plus? What is B plus? It's battery power. The thing is that battery power, once the engine starts, the generator alternator starts doing its job, we see that 12.6 to 14.5 volt range, right? That's where ideally where we are. So therefore, if you are doing a dynamic voltage drop testing, what dynamic means is that when you do voltage drop testing, the circuit must be on. Okay, let's get that clear. Circuit must be on. So if the circuit must be on, that would mean that that voltage could be at 13.2, 13.8, 14.1, whatever it is. We have to use that as a reference. So if I am doing a voltage drop test, let's say I'm doing it across a lift pump, like I'll talk about here in a bit. Let's see, I got 12 volts at the lift pump across the lift pump, but yet the battery has 14.2. Gee, am I dropping voltage? The answer is yes. So in this case, that's telling you there is indeed something wrong. Now, some people will argue and say, well, wait a minute, Tony. The lift pump has 12 volts. Yeah, but it doesn't have battery voltage now, does it? So in this case, anytime you do voltage drop testing, you need to reference first what is your source power and how much is your source power. In this case, how much is the voltage. So any testing, like the slide says, requires you to first measure that battery voltage. But let's keep in mind, everything in the vehicle will need battery voltage. I mean, we talk about NOx sensors, for example, and NOx sensors on diesel, they actually use standard battery voltage. So in this case, that battery voltage can actually be, once again, 13.8, 14.2, whatever that might be. So therefore, your job is to, again, verify that you do have your correct source and reference of what you're supposed to have. But before I lose you, again, voltage is pressure, correct? So in this case, when we've looked in the past, talking about basic electrical, we talked about amperage. And when we talk about amperage, we understand that amperage can vary. So the classic example I've been giving for quite a long time is if you look at a fuse box uses battery power. And in this case, if you got battery power going to the fuse box, as you can see in the picture of the slide there, what varies? I mean, I see 15, I see 10, I see 20, I see 30, right? That's telling you that all of the circuits using the same amperage? And the answer is no. I mean, I see 60 amps over right here, right? I see 30 amps, I see 10 amps. But again, there's a battery cable coming from the positive post of the battery going to this fuse box, and you're going to find out that it is using indeed battery power. However, that's voltage pushing it. But what's moving through the circuit is the amperage. So again, that's what we see happening. So let's get one thing clear as we approach and talk about more about this is the fact that what makes things work is actually amperage. What's pushing that amperage is, again, the current flow. I mean, excuse me, the voltage. So keep that in mind. Again, amperage can be the same. That's why we said in the past from a previous slide that what are we going to see different that carries in the circuit is the actual wire gauge size. What is the wire gauge size? Because obviously if we're going to carry more amperage, we need thicker cable. That's pretty much self-explanatory. But when we see circuits from manufacturers in the past, and let me tell you, if you look at a Duramax, for example, not that I'm picking on the Duramax, but if you look at a Duramax like an LLY, you're going to find that an LLY has this red box there in front of the engine on the driver's side, and you're going to look at the gauge size. So if we actually have 120 amp alternator, 140 amp alternator, whatever amp alternator, right? No matter what truck you're working on. And in this case, your gauge wire is too small, let's say 14 gauge, 12 gauge, or even 10 gauge, or even smaller than that. In other words, depending on the gauge size, if it's not going to carry that 110 amp peak, then you're actually finding out that it is underwired. So as we will show you voltage drop testing, and hear me correctly, as we show you voltage drop testing, can the gauge of the wire cause the high resistance because of the fact that it's underwired? And the answer is yes. So a popular modification that I do on diesel vehicles is that I often will add another battery cable, dual eyelet battery cable. I'll just order from local auto parts, which can be 14, 15, or whatever gauge. And what I do is I run it from the bat terminal out to the positive post of one of the batteries. Did I just give current flow another path? Yes, I did. So in this case, that actually helps in the charging process. But if that alternator is pushing, right? If it's pushing that voltage, is pushing that amperage, and it's struggling to because the gauge is so small, right? That's going to actually cause a lot of work, and it could heat up that alternator and eventually shorten its life. So when you see situations, or when I see situations, where we have repetitive failure after 3 months, 6 months, a year of an alternator generator, you often begs the question, is it because we're working with very underwired circuits there? So especially on the charging circuit, let's keep that in mind. So the voltage can be the same, but the amperage a circuit carries will determine the size or gauge it actually requires. So keep that in mind. Now, in the past, I've shown also this diagram where I was talking about, what's going on here with wiring. And in the past, like here, this General Motors wiring diagram used to tell you on the wiring diagrams the circuit number, but also the thickness of the wire. But you're going to notice it's in millimeters, right? So as we look at 0.5 millimeters thick on this wire, we see 0.35 millimeters of thick on this wire. And not all manufacturers did this. Even to the day, a lot of them don't do it anymore. Like General Motors, they don't do it anymore. But just for information's sake, I know it's a voltage drop testing, but note that there are two different scales or units of measurement for measuring wire gauge or wire thickness. And in this case, it's either in millimeters. We see 0.2, 0.35, 0.88, 1.0, which equates to whatever size you're looking. So a 22 gauge wire would be 0.35 millimeters, while thick stuff, as you know, the number goes lower, the thicker the cable. You're going to find out that a 8 is actually equivalent of 8 millimeters, you can see there. So the diagram will show you, obviously, that as the number is higher on the American wire gauge size, the wire is smaller, while in the numbers actually coming down from 16 to 10, it gets thicker. So is there such a thing as zero gauge? Yeah, that's some thick stuff. And we're going to see the thick stuff like on ambulances or fire trucks. So therefore, that's what we see going on with wiring. Again, can the wire cause a high voltage drop? And the answer is yes. So your multimeter provides the ability to measure voltage, amperage, and resistance. So note that a multimeter can only measure up to 10 amps. So there are inductive ammeters to measure amperage. But again, those are for higher currents, because when you look at your meter, next time you do look at your meter, if you haven't taken an electrical presentation with me, look at the bottom of that meter, and you're going to see that that meter has a maximum rating of usually 10 or 15 amps. So therefore it's fused. And it's funny because every time we do an electrical class or I go to a shop and the work, it's funny because we find that the fuses are burnt on those meters. So you definitely want to do a check on those meters. Every manufacturer of meter will have their way of telling you how to check it, but you do want to inspect to make sure that fuse is not burnt on your meter. But remember, the maximum that a meter can handle is 10 amps if you're doing amperage measurement. But we're not going to be doing amperage measurements in this presentation because we're talking about voltage drop testing. So what is voltage drop testing, right? You're probably saying to yourself, okay, well, nice. Or why are we doing this presentation, Tony? Well, it's a dynamic way, and dynamic means that we're always going to measure voltage drop test with the circuit on. So if I'm testing a lift pump, it must be on. I can command it on with the scan tool, or I can go ahead and turn the key on, but it'll only be on for 15 to 30 seconds, right? Or I can test a computer or a module. In this case, what am I going to have on? The key. Key will be on. So dynamic means you are testing it actively. Okay, you're definitely testing it actively. So therefore, it's a way of finding if there is unwanted resistance in the circuit. Don't worry, we're going to show you some things. But again, we're looking for unwanted resistance. So therefore, if I got too much resistance in a circuit, we're definitely going to have, again, an amperage flow problem because it's going to restrict the flow of amperage and things won't work correctly. So modules, components that use battery voltage can cause intermittent concerns or issues. So you need a reference, which is actually battery voltage. So therefore, always remember that. Yeah, I'm repeating that. So let's give you the most basic examples that I've been saying a lot lately. Since the heat is coming on, I'm going to teach you hopefully something you've never done, but if you've done it, more power to you. Great. Air conditioning compressor has a clutch that engages with battery power, right? There's a relay that opens and closes in some cases, and that relay supplies power to the AC compressor. So that supplies positive potential, while grounding may take place through some ground location going in. So we have a 2-pin connector going to the compressor, right, to the front of that compressor. Again, we should see that wire there and the connector. So there is voltage applied to it with current flowing through the wires that are connected to it. So there's also resistance in the circuit, which is in the compressor clutch coil. But when you do a voltage drop test, you're ensuring that there is, again, battery voltage being applied. So even though there's a relay, there's fuses and so on in the pathway feeding that AC compressor clutch, you're supposed to have, again, battery voltage going there. Okay? So therefore, if that clutch is slipping because the clutch is not engaging fully, and you're probably saying to yourself, why is it not engaging fully? Because it's got a huge voltage drop. So let's say your battery voltage, well, the AC compressor clutch is on, let's say it's 13.4. What should you have at the compressor? 13.4. But here's the secret. Both leads must be on that compressor. Okay, both leads. So you're going to have to get a little bit magical and learn how to back probe and actually get on those pins of that compressor. So again, it does require battery voltage, and you're going to measure that voltage across it, because if the clutch is engaged, right, you're measuring that voltage drop across that AC, and both leads on the compressor. I say that again, both leads across, again, compressor engaged. What should you see? Well, you should see source power. So in this case, if source power, like I said already, is 13.4, you should have 13.4. Actually, I used here on the slide 13.5. So in this case, there's 13.5 volts. Ideally, you should see 13.5. So if, let's say I see, let's do extreme. Let's say I have 11 volts. right? So therefore, I'm dropping voltage in the circuit. Could it be on the grounds or could it be on the positive side? And the answer is both. So now what are you going to do, right? Okay, hey, I definitely have a problem. And this might be a truck that might have repetitive compressor clutch failure, right? In other words, every year we put in a compressor in. It seizes the front end. What happened when it seized? Well, it's because it was slipping so much, the heat from the friction of it trying to keep turning, right? Actually fried that whole front bearing section. So therefore it seizes that seizes the compressor. So that's what you're looking at. So once again, you need to do a voltage drop test. But again, you're doing it with it on and with you actually back probing the two wires. So you're not going to do the positive on the lead of the compressor and then ground it somewhere. No, 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 no. Hear me correctly. Both leads must be on that compressor. So again, you got to put back probes, you got to put leads, you got to put jumpers, whatever you got to do. That is the classic way to do it. So therefore, actually the only way you're supposed to do it. So it brings up a good point. Anytime you're doing voltage drop testing, you're not going to put one lead to positive or one lead to negative of the battery. No, 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 no. Both leads must be on the component you're testing. So if it's a lid pump, bang, right on the lid pump. If it's a compressor clutch, like I just said, boom, right on both. But what about a module? Like we said earlier, a knock sensor module. We're going to be back probing right on the knock sensor modules I just said. So therefore, that's what you're definitely going to do. Okay? You got any questions, please let me know. But again, that's what you're checking. So therefore, anytime you're doing any kind of component like AC compressor, you definitely want to do a voltage drop test. So therefore, want to identify that there's no issues. Okay, let's take it to the next step. All right, so therefore we have a high voltage drop. We had 11 volts to the compressor. Okay, I identified a problem. I'm supposed to have 13.5. I have 11. Okay, what do you do now? Now we go from ground, anywhere on ground, to the negative side of that connector of that compressor clutch. You're going to have to identify which is positive, which is negative on the compressor clutch connector. So you go from negative to negative and you take a measurement again with the compressor engaged, with the engine running, with the key on, and you're going to do that voltage drop. Again, you're losing. If I have 11 volts and I got 13 volts at the battery, I'm dropping what? 2 volts, right? So you're looking for that 2-volt drop. That's why we call it drop. So we're dropping 2 volts. So therefore, you're looking for that drop. So you're going to go from negative again, some kind of good ground, to negative of that connector of the AC compressor clutch coil. That's one measurement. If that one is close to 0, then therefore you're going to go to the positive now. And yes, you can go from positive lead of the compressor, back probe, to positive of the battery, right? Positive post on the battery. You just tested the trail between the positive wire that went to the relay, that went to maybe a switch or a fuse, all the way to the battery power. So you're checking to see if you're dropping there. So if I have 2 volts dropping across my positive lead of my compressor to positive battery, then therefore that tells you you got a problem on your positive side. So when voltage drop tests are lower than what requires from battery voltage, that means that you got a high resistance fault somewhere. That's what we're trying to identify. So what is the classic place where we see a lot of resistance on an AC compressor clutch circuit? That would be the relay. Okay, that would be the relay. And what does a relay have inside of it? Like we've discussed in previous courses, is contacts, right? And those contacts on the high current side of the relays actually got a lot of corrosion. That could be the problem. Now, could it be a connector? Yes. Could it be the grounding of the compressor? Yeah. But on the positive side, though, it could be even at the fuse. You know, we make a joke here because we get these off-roaders that like to take these trucks into water. They put the, the tube on the top to breathe the air, right? They're snorkels, they call them. And the problem is they immerse the whole fuse box underneath the water. Guess what's going to happen after that? Once it gets hot, and we're going to get corrosion from the moisture. So therefore, that can be a problem too. So once again, what I'm going to do again is I'm going to grab one of my leads and I'm going to go from, again, we're going to go all the way to the compressor. So for those of you that don't quite understand it, let me just quick show it. Let me grab my pen here. And in this case, here's my COM, and I'm going to put on my leads, and I'm going to put my other lead over to the back probe on. So I should ideally see what battery voltage is. So if battery voltage is, let's say it's 12.5 when I'm running it, which it shouldn't be, it should be above that. But if it's above that, whatever it is, I'm going to go ahead and see that behind. That's very important to understand. Okay. So therefore, that's the concept behind voltage drop testing. Hey, this AC compressor clutch coil is supposed to work with battery power. It should have battery power. Yet, I guess I should rephrase my line. I should say battery voltage. And that's what you're supposed to be seeing there. So there you go. So again, reiterate, AC compressor clutch requires that battery voltage. But what about starting in charging systems? They also require voltage drop testing. So when we look at, here's a worksheet. It kind of came a little scratchy when I imported it, but you're going to see a meter right here, right there. And we're going to take a reading here, and you're going to see another meter here. Now, if you understand charging systems, we are charging from the alternator, right? So we got alternator right here, and that alternator again has its output wire, does it not, right? So therefore, where's the output wire? Well, this must be ground, right? So if let's start off with ground before we get confused too much. Here's my ground, and you're going to follow the ground all the way. So therefore, everything around here is ground. Okay, so you'll notice that the meter is hooked up to the negative side of the battery right there, to the case of the alternator. So we're going from negative to negative, right? But we're on the case of the alternator. So hold on a second. Before I even do a voltage drop testing on the alternator circuit, should the engine be running? Yeah. Should I have as many loads as I can on, whether it being high beam headlights, the air conditioning, the blower on set on high? You want to put some draw on it because you want to get this alternator generator to work. And let's see what the voltage drop is. So we're testing the ground side. So we're checking to see if the path to ground has any resistance, right? So if the battery is going to get charged, right, it's not just positive, but it's also ground, right? So in this case, we're going to test the ground circuit. So what that meter is testing is, what is the voltage drop on the ground side? So let's start giving you some numbers. What is the number that we like to see? Now, you're going to think that I'm contradicting, but the way I was raised was 0.25. Okay, sorry, I'm drawing this with my mouse. But in this case, the maximum allowable is 0.25 of a volt. Okay, that's what we like to see. If you see half a volt, like some manuals I've seen say of allowable voltage drop, in my opinion, you're too high at half a volt. But again, 0.25 volt is very important. So if I see greater than 0.25 on the ground side, that's telling me I have a high voltage drop. Because people often say, okay, Tony, you said that the voltage is 13, right? Let's keep it 13. But, I'm checking to see if I'm dropping anything on the ground side. And you're saying that the maximum variation you like to see in a circuit is 0.25. Yes, it is. So therefore, what's 12 minus 0.25 would be 12 point what? 12.75, right? So therefore, that could be an indicator right there what's going on. Because I'm looking at the voltage drops. If I'm dropping greater than 0.25 across this ground side, we definitely have a problem. But what about the positive side, right? Well, here over here, will be my mouse. As a matter of fact, let me erase what I just did. So if we look at the positive side right here, you're going to notice right there that we actually have our meter lead hooked up there, but to the positive post of the battery or bat terminal behind the alternator generator. So we're taking a measured voltage drop to test the integrity of the positive battery cable and anything else that might in between, all the way over to the alternator. Now understand, if I've been doing this on a Volkswagen TDI, let me tell you, the Volkswagen TDI, it's way in the front, on an older TDI that is, it's way in the front where it's belt driven, and it runs all the way around and all the way to the driver's side where I see the battery, and it actually goes to the fuse box, right? And there's also fuses there. So that's a lot of connections you're testing to see if you're dropping. So therefore, this is a very good test to know, hey, am I dropping anything across the positive wire going all the way to the alternator generator? Okay. So again, going back, yes, I'm repeating, voltage drop is an indirect way to actually ensure that there is no unwanted resistance in the circuit. So what are we testing for unwanted resistance? The positive battery side that feeds all the way over to the positive terminal going to where? Going to the alternator generator. You see that? So very important to understand. So do not do an alternator test, do not do a charging system test, let me rephrase, sorry. Do not test. Here I go again, do test. In a charging system, you do want to test that you are going to do voltage drop testing. So do voltage drop testing when you're testing the ground side and the positive side of the generator prior to releasing the vehicle after replacing an alternator generator. So again, if I'm doing an alternator generator, I found out that I got a dead generator alternator, right? I'm going to go ahead and, right? I'm going to go ahead and, do a voltage drop testing. So a positive side and on the negative side. Easiest thing to do. But remember, the vehicle must be on and you got to have as many loads as possible on because you're ensuring there's no unwanted resistance. So just to recap on what I just talked about. Let's say I'm dropping 1 volt on the positive side. Let's say this meter reads 1 volt. I'm dropping 1 volt on the positive side. So that's telling me since I'm dropping, what caused the drop? Resistance. That means there's resistance there. So is this alternator fighting to get that current out? The answer is yes. So can we see premature alternator generator failure because of this? The answer is yes as well. Okay, let me know if you got any questions. What about the starting circuit? Same thing again, but this one's a little more involved because in the actual starter itself, if it has the solenoid on top of the actual starter motor, you're going to actually test the contacts in that starter solenoid, right? So you're going to see another voltage drop, but also between positive and also the lead going to the motor. That's what you're testing right there. So again, what should be the maximum amount of voltage drop we want to see here on each measurement? No more than how much? 0.25. So therefore, don't forget that 0.25. So once again, starting with negative here, we're going to see the negative post right there. We're going to see our meter right here, and it's testing the case. And this is where we see the most problems on light duty, medium duty trucks is the grounding, okay? The grounding going to the chassis. So what we find is that there is a lot of voltage drop. So you're going to think that it's easy. No, because you got the negative battery going to the chassis somewhere, right? And then from the chassis, we got another cable, and that could also finally go to the block or directly to, depending on what's set up, to the starter motor itself. So you might have multiple connections on the ground side, and that's where we see a lot of issues on the negative battery post. So that's, on the negative side, where we see a high voltage drop there. Make sense? So therefore, we see a high voltage drop there. Okay, that's all on the ground side. Okay, so that's what we see there. Now, on the positive side, positive battery post once again. As a matter of fact, let me erase again. Sorry. So as I look at the positive side, let me erase, sorry. We're going to find, again, there's our positive battery post. There's our meter doing the measurement. Again, and we're going to the positive battery stud, which is the bat stud going on the starter solenoid. That's what we're going to see there. Okay, so in this case, we're testing the integrity of this cable. Now remember, if you don't think this is a big deal, it is a big deal. How many times have we seen pretty much corrosion, which we actually have corrosion going inside? So the battery cable physically might look nice from the outside, but if I were to slice it with a razor blade and look at the inside to see the conductive surface, you're going to find out we might have migration there. We call it, again, migration, where we see sulfur and corrosion migrating through the whole inside of the cable. So just because it looks pretty doesn't mean that it's good. So therefore, definitely want to do these voltage drop tests, okay? So, but again, cannot stress enough this. And let me tell you, you might think this is basic, some of you, but I get a lot of shop owners calling me, can you please teach these guys how to test the starter circuit? Yeah, here's the testing. Yeah, we can engage the starter, we can test the starter, but if we're prematurely, right, dropping too much voltage, we're going to actually have a click, click, click type of situation where the problem might be in the connections or it might be in the wire. That's what you're looking at there. Okay, let's get these voltage drop. And by the way, if you want a copy of these diagrams that are showing the voltage drop, obviously if you're watching it on YouTube, you're going to be able to freeze it and take a picture of it. But if you'd like a copy of it, let me know, or let the people here at Lucas know, and I'll be more than happy to email you these diagrams. Hell, I even have a complete worksheet on this, on how to do this, because every time you do an alternator generator or a starter, you should actually be doing these voltage drop tests. As a matter of fact, There are auto part chains that now require you to do that. So you fill out their worksheet, they're asking you to go ahead and, test that to see if if it's actually working. So definitely want to do that. So what is the load in the circuit? Here's a good example. This is from my ATEC training. And when we are looking at a bulb or an LED, and it's supposed to work with battery voltage or 12 volts, it should have that, right? So I understand it says 14 volts. Let's ignore that right there for a second. But in this case, if it's working with source voltage, hell, I could use it as an example. Never mind. Let's use it as an example, right? Let me erase. Hold on. So if it's supposed to use 14 volts and it's got 12 volts, do we have a problem there? Yeah. That means we're dropping voltage, right? I'm dropping 2 volts. So again, that drop could be on the ground side, or it could be on the what side? It could be on the positive side. Everybody see that? So that's what we're looking at there. So therefore, it could be on the positive, negative side. So again, we would do a voltage drop test. So I'm going to put V, and I'm going to put D for voltage drop. And what we're going to do is we're going to go from one side of the bulb to our ground source. Again, on the positive side. Once again, there's my meter represented by voltage drop. So therefore, I'm going to go from positive post of the battery to the positive of that bulb. And I should be dropping on one of those two measurements. I should be dropping those 2 volts, or maybe both, right? Who knows? So what am I showing here on the right-hand side? Well, on the right-hand side here, I'm showing a circuit breaker right here. And a circuit breaker is a fuse, a resettable fuse, right? Or some people call it, yeah, I guess it could be called that. But anyways, what I'm trying to say is that we actually are dropping voltage across these 2 points. So if I have 0 volts, is that correct? Yes, because this is not a load. So the moral of the story is a voltage drop test is done across the load, like we already talked about the starter. We're talking about wiring, but not a conductor like we could see here, like a circuit breaker. So if this circuit breaker has been reset a whole bunch of times and it's starting to wear and tear, yeah, it's going to show a voltage drop, but again, it should not exceed no more than how much again? 0.2 what? 0.25. That's what you want to see. Y'all follow me? So hopefully that makes my point across, because we're trying to make sure that the circuit is working correctly. So as we look at a complete circuit, just to give you a heads up here, can there be voltage drops? I mean, let's look at a basic circuit. Here we could see that bulb is on, right? So therefore, we can have a voltage drop across the wiring, across a protection device such as a circuit breaker, across the wiring again, across a switch, right? We could have voltage drops across also the wiring again, and across a load where it should have the majority of the drop there. In other words, match source. So we want to have, ideally, what do we want to have here? 12, because my source is what? 12. That's what we want to see. Again, we could also have voltage drop across the ground side too as well. So we could see another voltage drop there. I got another diagram coming up that shows this. But in this case, what I'm trying to show, and that's what we do in electrical 1, is we actually will take a circuit with 1 bulb, 2 bulbs, 3 bulbs, and then we'll switch them around in places, and we're going to find out that the place of the highest voltage drop is the load with the highest resistance. So if I got 2 bulbs that have 2 different resistances, the one that has the most resistance is going to have the highest voltage drop. So that's the law that we need to get across, is that the point of highest resistance will have the highest voltage drop. So, but luckily, when I'm testing starters and when we're testing alternators and we're doing AC compressors, for example, it's always at those loads. You want to see it, the highest voltage drop across the loads themselves. So once again here we see the circuit. Will I show voltage drop the way the circuit is illustrated here? Like if we're taking a test question for certification, should I see the majority across that load? The answer is no. You're like, why is it no? I should see it. Because the circuit is what? Is actually off. So in this case, you want that circuit to be on, and that's what you're going to see there. So, make sense? So in this case, always remember, anytime doing voltage drop testing, the circuit must be on, and that's what you want to do. Okay, there you go. So as you can see right here from this diagram, right, you're going to find out that these are all the points of where you can have a drop. And the reason why I show this is because think about now that lift pump once again. How much wiring and connector? So if that lift pump is way in the back in the fuel tank or it's on the frame rail, how many wires and connectors and grounds connections, and all the way up to the relay, then back to the battery, because hey, it uses battery power, right? So therefore, did it travel quite a distance on a truck? Yeah. So are there places where you can have a voltage drop? And the answer is yes. But make yourself easy. Make your life easy. If it's on the positive side, I'm going to go from positive terminal to positive side of the lip pump and negative to ground just to see if where's my highest voltage drop at. So there you go. Okay, so let's deal with the reality. We've shown similar diagrams. This is another one. Here we can see the lip pump relay, right? So we see the fuse and we see the relay contacts, right? This is a normally closed there, but it actually closes between number 3 and number 5. We can see that. And then you go to the inertia switch. Gee, how many places could I be dropping voltage, right? There's 2 right there on the positive side because Kendall's contacts wear out with time, especially at the relay. Yeah, but don't get me wrong, we've seen inertia switches. I got a video on my YouTube channel where I'm showing inertia switch actually fail. So in this case, yeah, we could have voltage drops there. But however, this is all going to the lip pump. So therefore, as I look at my lip pump, you're going to ask me, well, Tony, how do I do that? Well, if you can get to this lip pump, like on this Ford 6.7 and 6.0s and early 6.7 power strokes, I know you can get to the lip pump wire, and there's the connector number right there, 1392, and you're literally going to do a voltage drop test across those 2 and see if you have source voltage. Once again, is source voltage, yes, I'm repeating myself, if source voltage is 13.8, what should we have across those lip pump contacts? We should have how much? We should have actually, again, 13.8 volts. See that? So if I don't, then I'm going to do a voltage drop test across terminal 2, right? I'm going to put my meter right here, and I'm going to take it to what? To ground. So if I have, again, using my crude example of 11 volts, and by the way, these numbers are not unrealistic, okay? I have seen 11 volts going to a pump. So the question is, where is my high resistance at? Why do I have low voltage going to the pump? Then therefore, it's time to test, right? So if I'm down there, I can back probe terminal 2 right there, right? And what I can do is go from terminal 2 over to what? Ground. And again, I'm checking voltage drop across there. So that's what you're testing there. So what about positive? Well, terminal 1 right there. And I'm going to go all the way to what? The positive post of the battery to see if I'm dropping those. What is it? 13.8 minus 11 is 2.8 volts drop. There you go. So think about this. If there is low voltage going to the pump, as we just said, we just did a voltage drop, we only had 11, right? Will that pump turn slower? Will you have a pressure problem? Yeah, you will. So that would mean if I got low lift pump pressure, right? If I got low lift pump pressure, it's could it be also not just a bad pump, but it could also be what? It could also be that I got a huge, voltage drop across the pump. See that? So I can't tell you how many times we have seen this time and time again. They put another lip pump. They put another lip pump. Put another lip pump. Gee, my pressure's still low. Well, gee, did you do a voltage drop test across? Or what about if these pumps go out fast? In other words, they don't last 3 months, 6 months, 8 months, whatever. You're like, why? Well, if you understand, like I said in a previous one, if you don't understand the power formula, if voltage drops, amperage rises, right? So in this case, amperage can rise and it'll draw more amperage, and if that means it's going to get hot, which in turn can destroy the pump. But if the resistance is really bad, it's going to demand more amperage, but if it's not getting it because there's so much corrosion at that ground or so much corrosion at that relay, that can be our problem. So when you look at a computer, same thing too. I decided to use a Ford computer still because they're the easiest diagrams to demonstrate this. So yeah, I kind of cheated. But you're going to notice that a PCM has a PCM power relay. So there it is. So there's our PCM power relay. And you're going to notice that that supplies power to what? As this relay contacts close, you're going to see power again connect over and feed multiple circuits that feed. And if we follow F76 fuse, you're going to notice it goes splice where it feeds power to the actual what? It feeds power to the computer. So there we can see that. Oops, my mouse won't let me go. There we go. So here we can see all the voltage power there. All right, so let me erase here. How would I do a voltage drop test on the positive side? Well, on the positive side, it's very simple. You're actually going to probe, from here to what? Well, on the other side, and I did this intentionally, on the other side of this computer, there must be what? Ground. So if I'm legitimately doing a voltage drop test of my computer, I'm going to go to the terminal 1 to whatever terminal, let's say it's terminal 36, let's say, right? Terminal 36. I'm going to go to terminal 36. I'm literally doing a voltage drop across the computer itself. Now again, the connector must be on. You're going to back probe and you're going to actually do these tests. I'm going to go from terminal 1 to 36. Then I'm going to go from 1 to 36 and 5 to 36 with my meter in between, right? And I'm going to measure that voltage drop there. So in this case, what you're simply just doing is ensuring that there is no voltage drop, because when you open a circuit, let's say you're disconnecting the main connector going to a computer, C1, C2, whatever connector it is, and whatever application, you're going to do voltage like this, or some of you will ground the meter and measure voltages, right? No, that's just checking for pressure. In other words, voltage, but it doesn't tell you, again, if you actually have a voltage drop, again, across the computer. So it can fool you, because when you have it disconnected, the circuit is open and there's no amperage flowing through the circuit. So that's something you got to verify. Make sense? Am I making my point here? Yes, I hope I'm making my point. So therefore, I understand if I was a manufacturer instructor teaching right now, those manufacturing instructors tell you you do not back probe. And you know why they tell you not to? Because they don't want you to hurt the insulation. So you got to do it right, I guess what I'm trying to say. So know how to back probe without hurting the insulation. Though I got to tell you, some of the latest pigtail connectors and connectors, God, they're terrible and they're already bad as it is. So in this case, it gives you also an opportunity to test to see or look how those connectors look, because we're getting a lot of corrosion problems now. And it ain't because of you doing voltage drop testing. It's because of what? Poor design or poor pigtail design. That's what you got to look out for, because it's starting to plague us. These resistance faults and causing voltage drops. There you go. So in this case, that's what you want to do. So now let's go back in time. I've fixed many old 12 valve or 24 valve, 24 valve Cummins, and those use a VP44 pump. And here is a diagram. There's your injection pump wiring right there. Okay, and you're going to notice that needs a good ground. So you'll notice this splice and shares ground with the ECM, but it has its own dedicated ground going to it, which if we follow this diagram, it'll lead us to it. So one thing I like to do on a VP44 after I replace it, or if I'm doing diagnostics, is I'll go from this pin right here, which is pin number 6. I'm going to go to pin number 6 right here, and I'm going to go from there. There's my meter, voltmeter, and I'm going to go straight to what? Ground. I'm doing a voltage drop test. See if there's somewhere in this path, there's what? Unwanted resistance. That's what I'm checking there. But what about the positive side there? So what do we see here? We see all these wires. There's got to be some kind of what? We got some kind of power coming in. So there's your relay output power coming in, and that's your positive, and we're going to put our meter there and go to positive of the battery there. And let me tell you, that's why my policy has been, and I've learned this from voltage drop testing through the years, is that if I'm going to replace a VP44 pump that's got those death codes, I will, policy, I do replace the relay. So therefore the relay is also replaced there. So keep that in mind, because hey, it needs battery power. We got to do a voltage drop test across it. So I'm going to see if I got unwanted resistance. So how would I do the final voltage drop test? The one that I've been pushing is that I'm going to go from here. Actually, let me erase. I'm going to actually do a voltage drop test from pin number 7 to what? Pin number what? Pin number 6 right there. And that's my voltage drop test that I'm doing there. See that? So again, that is testing it right there on the connector. Yes, I had to take the cover off the connector. I had a back probe, and I'm doing a voltage drop test across the actual pump itself. There you go. So remember, to find out where the unwanted resistance is, again, I go from positive, positive, and negative to negative, like I showed earlier there. So definitely very helpful and easy to figure out when you got issues with the VPs there. So, make sense? Hopefully it's making sense to help you out. Now, the classic story some people ask me to talk about here. Let me switch here. I actually came out with a bulletin, and I'm going to actually switch. So give me a second here. I'm going to stop my share. And yes, it's going to show my ugly mug there. And what I'm going to do is I'm going to switch over here. And I should show it here. Oh dear, I didn't open up. All right, well, let me stop the share. Hold on. It actually is not there. Why is it not there? All right, while I load this up for you, and excuse me, but it is worth the wait here. Don't get all bent out of shape here. But is 6.5. How many of you guys have heard of a PMD, right? Ever heard of a PMD? Some of you may have heard this, some of you not have heard this. But the PMD is actually an issue that we had for a long time. And for the love of God, where is it? So therefore, why were PMDs failing? Well, PMDs were failing because of what? Well, when I came across the problem, and this is, by the way, my first diesel I ever learned. So, okay, here it is loaded. Let me get you back up here and let me share it. And again, if you like a copy of this, let me know. I'd be more than happy to share it with you. Now, in this case, this was a bulletin that I came out with years ago. This is old stuff. But we had a lot, not all, but a lot of the PMD issues, which is a what? A module here. So it's a slave module that works with the computer. So let me zoom it up a little bit. Let me get to my controls here. Where's my zoom? There it is. God, this thing's coming up. There we go. All right, so in this case, when we look at a PMD, what was the classic voltage drop issue that we had? Well, first of all, this is where, again, that Watts formula comes in, like I've been talking about before. Because what this PMD drives is that it actually drives this guy right up here. I hope you can see my cursor right there. And that is that big coil. You ever looked at that DS pump that actually has that massive coil in the front that actually controls a plunger? Now, in this case, you're going to notice it's already grounded, right? It's showing ground right there, okay? Now, in this case, we provide power that's actually turning on and off. So when we saw that we're having issues with PMD, and I came across this since I was drilled in GM Electrical 1, drilled over and over and over again about voltage drop testing, was that when I saw the PMD, we saw that there's ignition voltage right here. Okay, everybody see the ignition voltage? Pink and black wire. And we have our ground here. So therefore, we got to have a ground over here. So in this case, this is our grounding. And again, this is the solenoid high. Okay, this is what turns on that coil. Sorry, I don't have the complete image there. But in this case, it is going over there. So what I just simply did is I went from D to what? I turn the truck on, go from D to, again, the fuel solenoid low. Okay, and what we were doing is a voltage drop test. But before I even started going to the solenoid, I said, let's go from there to ground. So you'll notice there's my closure ground, there's my closure signal, there's my fuel injection control, right? That's the signal. So this is ground right here. So I literally did a voltage drop between B and C is where we did our voltage drop testing. So guess what we're finding out? And if you're working on 6.5s, I highly recommend you to do the same, is that, okay, here's my battery voltage. I got 12.9. Okay, how much should I have at the PMD? I should have what across it? Between D and C, I should see how much? 12.8. So in this case, this is a popular test that I recommend on this bulletin that I wrote, where you're going to test voltage drops across this because it's a popular problem. Now you're probably asking yourself, where do we see this? Well, that peak and black wire on terminal D, what we have found is that that peak and black wire is on the earlier model 6.5s, we're going through a fusible link. And what is a fusible link? A fusible link is a few gauges smaller of the actual wiring. And they do that intentionally that in the event it gets hot because of high current draw, it burns it, right? Well, what we recommend is put a relay in the circuit because by putting a relay, and if you need diagrams on that, I'm maybe more than happy to get those to you. But in this case, it ensured that we're getting full-blown battery voltage going to terminal B. That's where the problem was. So therefore, since the coil was not receiving full battery voltage, what that meant, that it was actually drawing more amperage, which in turn fried the PMDs or tripped them. Actually, better yet, they were tripping them because they did have some type of thermal protection. Now you're probably saying to yourself, what do you mean by thermal protection? A circuit breaker. Okay, that was resetting. That's why some of you saw that if you let the truck sit for a while, the truck would restart. So if the PMD actually opened up because it saw too much amperage, and then turn, the thermal circuit breaker would open up, and in turn what happened is the truck would stall. So there's your problem. But as soon as it cooled, what would happen? It would actually what? It would actually go ahead and reset itself, and now the truck would run. And that's what we saw those issues. Make sense? So definitely want to do a voltage drop across that because that'll definitely tell you if you're dropping any voltage there. But like I said, on most 6.5s, yes, it could be on the ground, but it's mostly found on the positive pink and black wire circuit. So that's where you want to put a relay in there. So because you want to eliminate that fusible link. So therefore that causes little problems there. So there you go. So in this case, definitely a big problem. So there we showed you another case where I do that. Now, just for the sake of, I do show the voltage drop test and I do describe it in the bulletin I wrote, but we also found that the issue could be caused by a quad driver circuit that was used on these computers where it could actually be shutting down too. So therefore, that's another subject in itself. But since we're just talking about voltage drop testing, we definitely want you guys to get an understanding of what's going on with that. So therefore, definitely want to do those voltage drop tests there. So make sense? So let me go back to my slides here. Give me a second here. Again, if there's any questions about voltage drop testing, please ask. We'd be more than happy to answer those questions there. So now let me go back to my slides. There we go. PowerPoint slides. So there you go. And boom. All right, we should be seeing the VP44 where we left off there, right? All right. So one thing that we have said over and over, because the subject is brief but yet very powerful, and that is that voltage drop testing is going to affect. So as we backtrack here, we see that this is causing a lot of issues with misdiagnosis when you're doing no voltage drop testing. I guess what I'm trying to say is, and I don't want to get you confused. Let me stop. Start over. If you are not doing voltage drop testing here by measuring the voltage at a component like a computer right here, like I did with 1 to 36, 3 to 36, 5 to 36, you're really going to sell yourself short because you're going to be maybe replacing a computer because you opened the circuit. You went ahead and tested voltage, but you did a static test, not a dynamic test. So in this case, what happened was that you didn't verify proper power. You put another computer on it, you still got the intermittent issues. And you're like, well, it had to be the computer. Well, no, because you didn't do a adequate voltage drop test there. So in this case, you need to do it as I tell you, because that's going to tell you dynamically what is going on with the voltage. And I can prove it further. Simply, you can start off with your scan tool if you want. Well, what do you mean by a scan tool, Tony? Well, did you know that a scan tool will display the battery voltage, right? So in this case, that battery voltage will be displayed. So if that battery voltage is, I don't know, 13.5 once again, and you measure it on your battery itself and you see, 12.8, or excuse me, you have 13.5 at the scan tool, but you got 13.9 or 14. Are you dropping voltage? So that's a quick way, to know what's going on. Hey, again, another example, 14.2 on my scan tool, right? But yet, at the battery, you should have what? 14.2. But if I got, on my scan tool, I got 12.8, but yet the battery has 14. Whoa, we're dropping more than, just shy of 2 volts there. So that's a classic way I could try to persuade you to understand that, yeah, you are dropping volts. And you're like, well, it still works, so I'll let it go. No, eventually that's going to cause problems because like we said at the beginning of this presentation, is that if voltage is low, right, that amperage is going to be impeded. That means there's resistance, so it could lower the current flow in that circuit. Make sense? All right, that's what you're looking at there. So hopefully it is helpful. All right, let me erase here. And our last subject here is min-max, like I introduced earlier. So I'm diagnosing this truck. I remember this truck I diagnosed years ago. And in this case, this truck would stall. And I tested everything. I'm like, I'm at my wit's end. Because it all of a sudden would die. So it definitely was power related. So I said, I checked power at all my circuits. I did voltage drop testing. Everything is looking good. I don't know what's going on. So I must be losing. I wiggled and jiggled wires. And damn it, I can't find the problem. That's where min-max comes in. So like I told you at the beginning, on your meter, you're going to be able. So here's what I did. I hooked up my meter here on terminal 1, let's say, right? That's one of my battery feeds. But I know that these are all spliced together. So unless I have a connector, I will visually verify the connections on 1, 3, and 5 right here, right? Okay. So I know that if I lose it here on pin 1, I'm most likely losing it at pin 3 and 5. Agreed? Because they're all spliced together, splice 102, right? All right. So what I'm going to do is I'm going to hook up my meter. I'm just going to measure voltage, and I'm going to ground my meter. Yes, I'm going to do it this way. This is the way some of you do this. But I'm going to set up my meter. I'm going to hit that min-max button. I left my meter over here to my right, but it's kind of a pain in the butt to get to, sorry. But what I'm going to do is I'm going to hit that min-max button. And what I'm going to do is I'm going to go ahead and have it record. And it'll say record. And I'm going to let it record. Now at that point, I'm driving with the truck. And when the truck finally dies, I'm going to leave the key on. Hopefully I'm in a safe area where I can pull the side of the road. And what I'm going to do is hit the maximum and the minimum. What was the maximum measurement? Now, mind you, the key's still on. So if it says 0 as the minimum, what happened to that circuit? It went open. You follow what I'm saying? So the maximum should be battery voltage, and that's what it displayed. But if the minimum was battery voltage and the maximum was battery voltage, then I did not lose power there, right? So that's where min-max can help you, because it needs to show that there's constantly battery power there. That's what you're looking at there. So therefore, you should have full battery power, again, going to the computer itself, but it should never drop. But if the truck was dying and I was losing because something's going on in that circuit that I'm losing power, then min-max is a great way to know if you're losing it or not. Now, can I do this also on the ground side? Yeah, I could hook up my meter from negative terminal of the computer, one of the terminals, and then I could go ahead and hook it up to positive and see if I maintain voltage. If I do lose the ground or I drop the ground, then I'm going to look at the minimum and the maximum. So it does work very well. So hopefully you guys can see the benefit of doing that voltage drop testing there. So, but excuse me, not voltage drop testing, but your min-max mode to test your minimum and your maximum voltage. Sound good? So that's a good example of using min-max mode. So we've covered quite a bit in terms of identifying circuits, but let me go back to the beginning, even before I talked about the AC compressor, and that is you have to know these guys right there. Again, voltage, known as the pressure, and amperage, but what affects one and the other. And that's where Ohm's law comes in. Oh no, Tony, don't talk about math. Really? A number over a number means divide. A number next to a number means multiply. That's it. All you need is one of these guys and you can do the figure eight, you can do the math, right? So it's not that hard. So in other words, mathematically, can we calculate what's going on with Ohm's law? The answer is yes, and that's what I'm trying to tell you here. So in this case, you got to know them first, though. Voltage is the pressure. Have we made my point there? That's what's pushing. Now that I think about pressure, let's think about this. Gee, when I put a garden hose and water's flowing out of that garden hose, right? Water's flowing out. You like that sound effect? Water's flowing out of that water hose, and you put your finger over it. You're creating more pressure, but you created what? A restriction. Doesn't that sound like voltage drop? In other words, you got a voltage drop. Voltage is what? Pressure. So therefore, when you put your finger over it to create more pressure, you create a what? A restriction. So we said that flow is amperage. So when there's a voltage drop because of resistance, you create a pressure. And that's what we see as a voltage drop. Damn, that's pretty good, Tony. That's pretty good. I like that. There you go. There you go. So in this case, there you go. You're trying to make that point across in terms of, how do these relate with each other. Now, let me get to that Ohm's law thing, because it's all mathematical calculable. We talked about the power formula where we said voltage times amp equals watts, but watts is what a motor draws, like a starter motor. So in this case, if that motor wants 200 watts, it's going to get the battery voltage and whatever the amperage calculates to. But if the voltage drops, the amperage goes high because that motor wants that wattage. That's what we're trying to train you on the electrical side. Yeah, I guess I'm throwing a little to push you to take electrical training. But in this case, what I'm trying to say is that mathematically, they're all calculable and they can be calculated. But again, the purpose of the voltage drop test is to make you understand that, hey, I need to know if there's unwanted resistance in the circuit. So very, very important to do. Now, earlier when I started the presentation, I talked about a knox sensor, right? So what I'm just simply going to do, I'm going to find a space here to actually do this here. Here we go. So let's say, just to sake of argument, let me get my, there we go, there's my marker. In this case, here's the module itself. Now, I wanted to use a module. I said, you know what? No, Tony, you can do it by yourself. We talked about CAN bus last time. So we talked about CAN, right? There's your CAN. So therefore, there's a CAN positive and a CAN negative. So those are two wires coming out of the knox sensor, okay? What are the other two wires coming out for? They are what? They are your positive and your what? Your ground that turn on the module itself. Now, this is a knox sensor. See that? So in this case, this is our CAN high, and this is our CAN low, right? Yes, it's primitive in the form of whiteboarding it here. But in this case, what I'm trying to say is if we also have a knox sensor way in the back on the chassis, right? Can it actually have power and ground problems through time? Yes, it is. So corrosion or whatever it's exposed to, dirt, whatever, mud and water and all that underneath. So that is going to make it easy. So can I do, here's my meter. Once again, I'm going to measure voltage. Can I go again, probing the positive and the negative to do a voltage drop test on the knox sensor? The answer is yes. So in this case, is it getting battery voltage? And you got a particulate matter sensor back there on a Ford product and some GM products, right? Does that also require power and ground? Yeah. And the reason why I'm talking about this is because, like I just said, these are exposed to the elements, right? So in time, will we see voltage and ground problems with them? And the answer is yes, we will. So in this case, this is where voltage drop testing will come. So yeah, I'm literally going to be underneath the vehicle. I'm going to find those two terminals on the connector. I'm going to back probe. I'm going to go from the positive, negative, and I'm going to go ahead and measure the what? The voltage drop test. So that would mean that the key must be on, right? Now, if you want to have the engine run, that's up to you, but at least minimum, you must have that key on because again, when we do voltage drop testing, the key must be what? It must be on, and you must always do that when you do testing. So I cannot stress that enough, okay? You got to back probe, right? And you got to know how to do back probes. And by the way, there are many tool vendors out there that sell these back probe kits. I have the one from Matco. There's other companies, but if you're cheap and you want to buy them, you can do what I do. I go to local Walmart, for example, not to push Walmart, but I go to the fabric section of the Walmart. And they have these T-head needles, these for patterns. These T-head needles work very well. I bring them home and I'll actually sharpen a little bit on the grinder, but they're excellent for back probing and also hooking up your alligator clip to it to do a voltage drop test. So I highly recommend that you actually look at your electrical setup testing. A, have a good meter, right? Make sure remember we talked about that fuse, make sure that 10 amp fuse ain't burned. Get a good meter, make sure your fuses aren't blown. And what you also want to do is you want to get your jumper wires, right? I was at Harbor Freight and they sell a bag of these jumpers. Snap-on sells their pretty ones. I love the Snap-on ones. They're so nice with the 2 alligator clips. And then you got those that actually roll up that multiple vendors sell, like Matco, and Snap-on. They sell these ones that roll, but you're going to need jumpers in some cases to do a voltage drop test. Because if I'm doing voltage, or drops between where the ground is or positive is on a lip pump, like I've just been talking about over and over again, you're going to need some. So get your electrical, I guess what I'm trying to say is get your electrical stuff all set up, because that'll make it easier for you to, have your probes ready, your meter ready, and also your leads ready so you can do proper. Because that seems to be the sin when I go to shops and I'm doing testing. And, I just did a 7.3, for example, and this 7.3, if you've been around 7.3 diesels, Fords, you're going to find out that getting a computer is like an act of God to try to give you spirit there because of the fact that they're very hard to find in good quality. Even though there's a lot of vendors rebuilding them, we're having problems. But we have seen those IDMs and those computers fail due to the fact that what? That they had a high voltage drop going to them. So the problem was not in the computer, the problem was not in the IDM, even though it kept frying them. And turns out that we had high amperage draw because of that excessive voltage drop. So again, always remember that, you got to always keep that in mind. Yes, I caught that as I opened that slide. Yes, the higher the number, the thicker. No, the lower the number. Sorry, I was just testing you. There you go. Yeah, you're right. That's wrong. I see you're paying attention, but you're paying attention to this too about the voltage drops. You better be. Thank you. He is correct. That was typed wrong. The higher the number, the thinner or smaller it is. So that's incorrect there. I got that. I just saw it too, and I said, sorry. There you go. So there you go. So anyways, we talked about, again, voltage drop. We talked about the AC compressor. We told you all about that. We talked about the charging system, starting circuit. So definitely something you may want to do. Now, when it comes to other accessories on the vehicles, right? What are other accessories? From motors on your seats to actually your seat heaters and so on, where you may have a problem. You could have a high voltage drop there too, so you're going to want to go across them too as well. So definitely want to pay attention to that because it'll help you in your diagnosis of electrical problems. So get your meter, go get the dust off of it, and let's start using it to do voltage drop testing. So there you go, sir. I'm a tad early, but I'm good. So I'm about 2 minutes ahead where I wanted to be. So how are we doing, David?
We're doing very well, thank you. Great presentation again, Tony. Very informative. A lot of basics, but sometimes a lot of us miss the basics. So it's a good refresher and a lot of good detail. I have a
But
couple
it's
of
funny.
questions.
Oh, go
Pardon
ahead.
me?
Just a quick thing. It's funny because, you're just testing to see if this thing's got the battery voltage it requires. I mean, that's it.
Mm-hmm.
So if I'm doing a headlamp, get back on a headlamp. Do we have that battery voltage going to it? So
Right. Right. So a couple of questions here for you. When it comes to battery testing, can you just elaborate a little bit, or can you give us some information on how you go about testing a battery to see if the battery is good or not?
the battery itself.
The
All
battery
right.
itself.
First of all,
In other words, let's start with the very, very basics. Okay, is the
obviously visual.
input right?
Start off with the visual. Visually, how is that battery, right? How does it look, right? So how are the battery terminals? You got to clean the battery terminals. That should be part of your diagnostic routine. Step two of testing a battery is that we're going to disconnect one battery on the other side, and we're going to, if we got two battery or three, whatever arrangement you got to test them individually. So at that point, there are two ways of testing a battery. Number one is what we call capacitance testing, and the other one is carbon load or load testing. That both of them, believe it or not, work great, and there's many shops out there that are still using it. So carbon load testing means you're putting a load on it, and some machines are doing your homework for you. Some of them are manual, but you're going to put half the CCA load on it for 15 seconds, shouldn't drop average of somewhere around 9.5 volts. Capacitance testing is telling you, it'll test it for you. It'll even tell you if you have a bad cell as well. So those are my favorite. A lot of shops nowadays have those where they're doing capacitance testing, where they're entering the CCA, the temperature. That works very well too as well. So you can go either way on it. So there you go. That's how you test the battery.
Okay, thank you, Tony. Second question is, I had a friend a couple of weeks ago who thought he's got a newer vehicle. We won't mention what type of vehicle it is, but he thought, well, I'll save some money instead of taking the vehicle somewhere to have the battery replaced because it needed a replacement battery. He would do it himself. So he disconnected the battery, took it to a shop, okay, to purchase a new battery, got the new battery, put the new battery on the vehicle, hooked it all back up, and then come to find out the electric windows don't work, the seats don't work, the heated seats don't work. So he ended up having to take it to the dealer in order to have the thing scanned, okay, and put back into working order. What does one do these days? I've heard that, you shouldn't disconnect a battery anymore totally when you're replacing the battery. what do you need to hook up to it in order for it to maintain that voltage, and then put the new battery in there so that all that information is not lost? Do you know?
There were, and there are still people that will connect fairly not thick cables, but some jumper cables across the positive and negative. I do it actually, so I don't have
Yeah.
to reset memory, power, and all that. So therefore, we use a battery pack or some type of jumper box. And what we
Okay.
do is while we're disconnecting, connecting, we actually will always have power going to it, not to lose any of that memory.
Okay.
So, but the case you just told me where things don't work sounds like he reversed the leads.
Ah, okay.
So that which has been known to happen too. So therefore
Yeah.
they do that. Or some vehicles out there actually have auxiliary. Like for example, I was working on this Jeep Diesel. I forgot what year it was, but both wires for ground and positive had auxiliary wires going to, and they were also black.
Uh,
So I could see how and that's what happened. He crossed the wires
yes.
because he did that kind of thing there too. So yeah, crossing wires could be a bad thing. In other words, you can actually kill
Sure.
modules that way. So
Sure.
food for
All right.
thought.
I believe that's all the questions that we have at the present time. So once again, Tony, thank you very much for your presentation. Excellent as usual. And thank you all for listening in and tuning in to our monthly webinars. We will have another webinar in June. I don't have a date and/or subject for you at this
Well,
present
yeah, we
time.
got to give you. Hey, by the way, if you guys have any suggestions, let them know. There's their numbers. Let them know if you have any subjects you'd like to hear me talk about. So yes.
Okay, that's a very good point. Appreciate it. Yeah, and any feedback you have would be greatly appreciated as well. So thank you everyone for spending your lunch hour with us, and we look forward to seeing you in June. Thank you very much. Thank you, Tony.
Thank you.
Thank you. Goodbye.